Okay, here we go. Second derivative test to find the local extrema for the function. And basically the way the second derivative test works is if you have a critical point and the second derivative is negative, that means it's concave down at that point. That means it's a maximum. At that point, if the second derivative is positive, it's concave up. What if the second derivative is 0? Well, because we just did an inflection point, it seems like it should be something like this. Because this would be an inflection point, concave up, then concave down. But is there a case where you have a function where the second derivative could be 0 and it is a max or min? And the answer is yeah. And we've looked at this, x to the fourth. That's this guy right here. It's just a real wide parabola, and if I take the second derivative, I get 4x cubed, and the first derivative, second derivative is 12x squared, which is 0 when x equals 0. So at this point right here, the second derivative is 0, and it is a minimum. So when the second derivative is 0, that can be a minimum or a maximum as well. So basically what we're saying is if the second derivative is 0, who knows what it is? Okay, you have to check it out other ways. Okay, oops. So let me get rid of this, and then we'll go on with the problem. All right, here we go. So this is what you'd be looking at to do this here. Let's find the critical points. Y prime equals 240x squared minus 15x to the fourth. That's not easy to read. Come down here. So it's going to be 15 x squared times 16 minus x squared equals 0. That's kind of not a nice color to do. Let's change colors here. Here we go. How about that? My colors. So there we go. 15x squared equals 0. Let's not put too many equal signs there. Or 16 minus x squared equals 0. So this means x equals 0 or x squared equals 16. Now remember, you got x squared equals 16. Take the square root of both sides. That means x could be plus or minus the square root of 16, which is plus or minus 4. So my critical points or critical values are x equals 0, 4, or negative 4, right? Okay, so what do we need to do with those? We need to check to see when we plug it into our second derivative, what do we get? So let's find the second derivative. So that's going to be 480x minus 60x cubed, and let's check them out. Y double prime of 0 is 480 times 0 minus 60 times 0 cubed, which is 0. Don't know what that means, right, by what we did earlier. So this is really inconclusive. We're going to have to check with the first derivative. That's the only option we have. And we haven't done anything really like that before, so I made that worth like 1 point to check that, so very minimal there. So negative 4. Then if I plug in this, 480 times negative 4 minus 60 times negative 4 cubed. If I plug that in there, I get, believe, positive 1920, which is greater than 0. Okay, and I'm going to go ahead and write this. So x equals negative 4 is a local. You can always say it's local, because whether it's absolute or not, it's still a local max or min. So since it's positive, you can, this is concave up. So x equals negative 4 is a local minimum. and the minimum value is y equals negative 2048. That's what we get when we plug negative 4 into it. I'm going to write the next one a little bit differently so you can see a variety here. Y double prime of 4 is 480 times 4 minus 60 times 4 to the third, which is negative 1920, I believe. I just know it's negative. Is it negative 1920? I don't have a calculator handy. So I'm going to do this. I know that's a negative number. So it's concave down. So the point 4 positive 2048 is a local max. Okay, so I've got I got two ways to write it. I can write it like I did up here. X is the local min, and the minimum value is here. So I'm telling you where it's located. X equals 4, that's the location of the minimum, and there's the value. Or I'm telling you the point is the local max. That's fine either way. I'm also telling you here that on this problem with the with 0, I don't know what that is. 0, I don't know if that's a max or min, so we need to check it out. So I'm going to do just right over here just a simple first derivative test. So back up to my first derivative, I'll back down so you can see that over here. Y prime, if I plug in a negative number like negative 1, I'll get 240 minus 15 is positive. And if I plug in a number like 1, I get 240 minus 15 is also positive. So Y prime doesn't change sign. So X equals 0 isn't an extreme value. Okay, so there's no extreme values for 0, or at X equals 0, it just happens at 4 and negative 4. So you are done with this problem, but just to let you guys, give you guys an idea of what's going on here. I know at negative 4, I'm down here at negative 2048, and that's a minimum. And at positive 4, I'm up here at 2048, that's a maximum. And I know it goes through the origin. So just to give you just kind of a little idea, it's going to go like this forever that way and forever that way. Okay, there you go. There's your complete solution. Let me shrink it up a little bit so you can kind of see it all in one shot. There you have it. All right.